When asked to speak about precision horticulture from a general perspective as a segue then into some of the more detailed presentations you're about to hear, it's a bit like asking someone to talk about Australia in 5 minutes. Precision horticulture, like precision agriculture, like precision viticulture, you name it, at the end of the day, agriculture, viticulture and horticulture are becoming more precise. So does it need its own title? I'm not quite sure. So I thought I'd call it about today and possibly tomorrow. As a research scientist working in this space, it's always about here today, possibly gone tomorrow anyway. So let's chat a little bit about where we start. Of course, the notion of a precision form of agriculture started with the GPSS, or the Global Navigation Satellite System. And basically, it is just a little mobile clock, a very accurate clock, that compares its own time with time signals coming in from satellites around us. And we use that information to position ourselves on the ground. If you know where you are on the ground, then you can start measuring things in your orchard or in your vineyard or in your crop, and possibly even actioning some form of management at that same location at a later time. It really is about spatially enabled agriculture. That's how it started. But of course, with a whole raft of new sciences emerging in the last 10 years, and the fact that we are reinventing the way we do basic agronomy using some of these tools, it's no longer just about space-enabled tools. It is around tools for measuring, tools for controlling and manipulating, and tools for recording and interrogating. So precision, any form of agriculture, is so much more now than it ever was when we first coined the phrase in the early 90s. And of course, in the grape and wine industry, which is, I guess, the first real foray into a form of precision horticulture in the early 90s, it all started when we could put yield monitors on board our harvesters. Because if you coupled the ability to weigh the fruit coming off the vines with the ability to measure where you were in the vines, of course, then we could start mapping our production, not only just in terms of yield, but hanging economic numbers to it in terms of gross margins and understanding which part of the vineyard was subsidising what other parts of the vineyard or the other parts of the particular farming operation. And then, of course, once we could weigh the yield and locate that yield as we went from the harvesters, other tools such as soil sensors, electromagnetic EM38 type sensors started to appear, and we could then start looking at the interaction between the production of that system and the basic physical properties of, for example, a soil. And we all have learnt in the 20 years or more since precision agriculture started in its formal sense that, you know, soils have a lot to answer for in terms of the variability in our crops and pastures and orchards. You all knew that anyway, but it's about knowing how much they varied and what the physical and the quantitative impacts were on the production system. That was where the revolution started. So that's the story about precision ag, precision hort. Now, of course, our ability to locate ourselves on the ground involves the use of the GPS, and we know that the gold standard of positioning accuracy is around 2.5 centimetres on the ground, what we call RTK, or real-time kinematic GPS. And of course, in order to run an RTK positioning system, you need access to a GPS receiver on your implement or your harvester, which means you need access to the satellite signal. You have to pay a subscription. You need then also to get your correction signal, and if it's a network cores RTK, that means you need a mobile phone reception to beam in the signal. You need to have your mobile phone data card alive and operating, and of course you've got to have damn good reception. Now, under the pressure of a harvest, how many of those things will fall into place when you get out of bed and scratch yourself for the start of a day? Crikey, I forgot the data card. Damn it, my data plan has expired. Damn it, I forgot to renew my GPS. So in other words, there are now moves afoot to provide that sort of positioning accuracy for farmers, not necessarily using what we conventionally understand to be the norm in terms of RTK GPS. An example, so in other words, we're looking a little bit ahead to give you a sense of what could be coming. What we call PPP, precise point positioning. It works like a RTK GPS, but rather than using a network of ground stations that are accurately located to provide you that correction blanket that you can work out where you are on the blanket and hence apply that correction, the PPP uses very detailed modelling of the ionosphere, the atmosphere above us. And for example, the Japanese government has just launched 3 satellites capable of transmitting, in addition to their GPS information, the timestamp, a correction signal which is based on this modelling. And so what that boils down to is that there are technologies soon to become available that will allow you to have RTK positioning accuracy with only a single receiver on your implement machine looking up at a satellite. You do not need access to terrestrial augmentation systems. The data from those on-ground systems are being used to create that correction, but it's all coming down from the same satellites that are giving you a GPS signal. So to give you an example, we just knocked over a trial here up the road at Jerilderie in a rice field, and if you look at this trial, to show you it in action, what we have here is a 2.5 centimetre positioning accuracy on the fly used, generated purely from a single a satellite receiver on the tractor. It's doing the GPS work and the RTK corrections. No on-ground terrestrial signals are required. And mind you, I should add, and James is going to talk a little bit about this in a much more fun way, that's a robotic tractor while we're at it. If you can drive 2.5 centimetres with a signal, you might as well not have a driver in there either. So, the whole confluence of robotics and new positioning accuracy type tools I think will offer enormous benefits potentially for this whole industry, because all of a sudden you don't need to worry about your mobile connectivity. Now, when you're talking about the current status and the rapid developments in agriculture, precision agriculture, precision agriculture was aided and abetted years ago by the use of satellite images. We had these wonderful satellites up ahead that we could get, 60, 50, 30 metre resolution images of the ground, and what a fantastic tool that was going to offer farmers, and boy, it was going to be the silver bullet for all your problems. Of course, nowadays, or since migrating from satellites to airborne imaging systems and now to UAVs, the promises are similar. We will still be the silver bullet for your problems, and it's not the case at all, because we're still using the same basic information, the image. But, of course, satellites and aircraft and even drones offer different aspects of flexibility and different quality of data, which have all different uses. And in our predilection for charging ahead to the drones, you've only got to stop and look over your shoulder and realise the satellites are evolving themselves. So, in other words, satellites, airborne imaging and drones, we have a wonderful suite of potential alternatives that can work together, not necessarily in competition, to offer a solution to growers. And why are we still interested in remote sensing? Well, you've only got to hark back to the 90s when we were using imagery in vineyards. For example, if you take an image of a vineyard at harvest and you look at the grape yield at harvest based on an onboard harvest monitor, generally speaking, you'll get no relationship between them whatsoever. If you take an image of your vineyard at flowering, you will often find a stronger relationship with the yield the following year, which makes sense, doesn't it? Because you've got sunlight onto your inflorescences, so your vines are going to be more fruitful, but it's in the following year that they bear that fruit. So we know that if you tactically use imaging, you can get some information around, for example, likely yield. And of course, the same applies to quality. It was in that mid to late 90s that we did the early work that demonstrated that there was a relationship, for example, between the phenolics in red wine grapes and the canopy vigour as measured using that magical NDVI, the Normalised Difference Vegetation Index. In fact, it's an inverse relationship. Where the canopy is dense, lots of leaf area, then you tend to find that your phenolics don't develop quite as well because of the sunlight shading effects of the canopy. The sunlight into wine, think of Richard Smart's sort of dogma and doctrine from the late 90s. But at the end of the day, we know that if you collect imagery of your vines at the right time of year, and we're talking at veraison, then you will often get a reasonable correlation between the canopy density map that you get from that remotely sensed product, used to be satellites and then airborne and now possibly drones, to some sort of variability in your quality. It's an inverse relationship, but it's significant. And veraison remains, as far as the industry is concerned, pretty well the time to be imaging your vines. But of course, in the earlier days of taking satellite and air photos of vines, we had to be pretty switched on in order to find the individual vines and to know where they were in the vineyard. If you look at an image like that, could you tell me where each and every one of the vine trunks are in that image? The only way you can do it is to apply really detailed geostatistics to it to pick out the very subtle differences in shape of those long linear blobs. And then you can use that to identify exactly where each and every vine is. It was a hard task in those days, and it's funny, we're only talking 10 years ago, because we only had 50 centimetre resolution to a metre resolution imagery. But it could be done, and it was then possible to look at the size of your vine canopies as well as the density, the canopy density. And people have been using that sort of approach to segment vineyards up to get different yields or quality targets met on harvest. It's nothing flash, you just drive your harvester through, 2 chaser bins, you present one chaser bin or the other depending on where you are in the vines relative to those, for example, 2 quality levels or yield levels that you're chasing. But of course things have come a long way, and you'll hear a little later on from James about the use of drones. We now have the ability to put very high resolution cameras on little birds that fly really close to the vines. So up in my neck of the woods, we use them to annoy the hell out of cattle. We do a little bit of mustering with them. We also use them to count cattle. We do lambing runs, trough runs, that sort of thing with them. The livestock industry, which is where our heart country is finding some use for these little guys. But there is some really interesting opportunities for the horticulture industry that really were denied the satellite and aerial imaging community. And that's because you've got these drones with really high resolution cameras, and it's called structure from motion. So that isn't a photo of a vineyard. That's actually a 3-dimensional model of a vineyard that's been created by a little drone flying at 100 feet up and down every 3rd row, just taking 30 frames per second GoPro images. And you can buy software off the shelf which will create a 3-dimensional model, which is all cool. You can spin it around and look at your whole vineyard from different directions. That's fine. But no, more importantly, you can actually determine the canopy volume, you can determine the porosity of the vines, you can look at the internode spacing and the number of shoots per vine by that live 3-dimensional model that's just created on the go. Now we can start talking about things like vines being in balance. Can we tell a machine that this vine is in balance, or what do you need to do, for example, when pruning to make that vine or to generate a more balanced vine? Because that word balance is a very nebulous one. It's easy if you're an experienced pruner to know how to prune a vine to balance, but if you were to explain to an itinerant worker, I want you to prune that vine to balance, what does that mean? So if we're going to train machines to do it, these are the sorts of things we have to do. We have to replicate what we see, and then we have to start replicating how we think. Lots of challenges. But if you can apply that to remotely sensed data, then as satellites become more and more or greater and greater resolution imagery, you can then step back and start scaling it up to whole industries and whole catchments. So we do a lot of work in the sugar industry, for example. Just using off-the-shelf commercially available satellite imagery. We use it to yield predict every sugar field in Australia. So we give those predictions to the mills so they know. Why? Because you can get a nationwide coverage of an image. So there's a scalability. So there's opportunities to mix the 2 technologies together. Here's some examples, where we're within 10% of yield prediction, and that's across entire regions. Just using satellite-derived indices, but are potentially scalable down to much more closer sensing technologies, and so forth. Even quality, plant nutrition. But at the end of the day, in terms of the shape of the hammer we're using, it's still the same. It's just the optical reflection and that so-called NDVI number that comes out of it, or derivatives. But of course, the way we approach data is different now too, and this is where the horticulture industry is going to get a whole new breath of fresh air, not from people like me, but from the fact that we've got people who are working in data analysis, statistics, what we call big data. Not only do we rely on the colour of a target to help it tell us about what it's doing, the canopy, but we can now look at the shape of the canopy and shape of hotspots. In other words, what we call feature-based image processing. And all of a sudden, we can learn more about what's going on in a structured canopy than we could in the old days when we just had colour. Just to give you an example, we do a lot of work with the avocado industry, right? Identifying trees, identifying the tree canopies and looking at the canopy attributes and hand that information to the growers. And you can be pretty cunning the way you do it. If you take a current image of an avocado orchard and you say where are the individual trees so you can catalogue which tree is doing what, well, we've got time series of data. We've been accumulating data for the last 20 years in some cases. Go back to the early planting imagery, identify the trees, tag them using statistics. It doesn't have to work very hard, and then reapply it back. to the evolving orchard because the trees don't move. So we've got all these other attributes that we can target around time series of data that we never had 10 years ago. So again, more opportunities. And of course, that very parameter that we measure, the reflectance from a canopy of an orchard using a satellite, we can now generate using handheld sensors. So that little device there, it's called a green seeker. It just flashes red near infrared light on the target and gives you back the NDVI. Well, the NDVI, there are 1,000 reasons why a plant can be green or not green, but what can that NDVI tell you? So synchronous detection, they're finding more and more uses in vineyards, for example, not only for providing maps of canopy vigour, but also because you can tune them to different colours, it's just the colour of the light that flashes. Then, for example, that's just a side view map NDVI of a vineyard. It's constrained by VSP wires, so you can't see anything from above it. So you've got to get out beside it and have a look. But also, you can characterise the shape of the canopy. Again, this was early work aiming to deal with this issue of vine balance. Now, of course, we have imaging systems that can move very quick and do it. But nonetheless, you can create that sort of information on the go. We put these systems in aircraft. You know, this is just a flashing set of LEDs. Well, you can buy souped-up LEDs, and we bolt them on the crop dusters so that they're already over the paddock or over the orchard doing some sort of spray work. So why not collect the optical data on the go? And the beauty about the flashing light approach is it doesn't matter whether it's cloudy or sunny or it's in the middle of the night, because it's got its own light source. And you just collect the information. And we've been doing a lot of work in crops, for example, not orchards, where we've been collecting data on the ground. We've got guys that have got them on motorbikes, two-wheel motorbikes, running up and down the rows. And our crop dusters at 50, 100, 150 feet above ground, there's no difference. So these are tools that are now available that can help us condition our thinking around, well, what is the future for the horticulture industry, for example. And of course, you don't give a technology talk without mention of drones, and you're going to hear a bit more today, but those same active sensors, thermal as well as optical, active optical, go in drones. So you can be scooting around on top of your crop or canopy, collecting information, and certainly we've been working with some growers doing that as well. But just to show you where it can go, if you're measuring something from an in-situ aircraft or vehicle, then you might as well be doing something while you're at it. The sensor on board our crop duster we use to control our fertiliser application. So what you see there is that's actually a recorded set of data. That's the crop duster flying up and down the rows. And on the right is the prediction of what the high, medium and low nutrition rates are ahead of the nose of the aircraft in the 5 seconds it takes to do a turn. Computing is so much faster than it was 10 years ago. So you can do some very, very fancy geostatistics on the go and then convert it back into something like an actuation control. In our case, it's for fertiliser in that particular wheat crop. Of course, here's another aspect of what I would call precision horticulture we're thinking about. Remember, there are how many thousand orchardists in this country? Can't remember, but it's quite a few. If people are going to have access to tools like this, which are at the moment $300, then can you as an industry utilise that information? Here's an example of a project we're doing in pasture. We have 32 growers around Australia using this to estimate pasture biomass from it. There is an app on a smartphone that will convert the NDVI to biomass. Every time they use it, it also crowdsources that information onto our server, which is located in New Zealand, I might add, to allow us to build even smarter algorithms, because we're collecting data from farmers. It's denatured. We're not interested in where it came from or even the time it came from. We're interested in the numbers that they are using this for. So we're using that not to keep an eye on them, but to create a better calibration algorithm, a more robust calibration algorithm, which comes back to them. If you crowdsource information, technical information from growers who are partaking in your trials or who may be growing for you under contract, how do you collect information off them? A, that it's secure, so this was the first challenge, and B, how do you gauge the reliability of it? And you realise when you want to start crowdsourcing technical information in a precise sense from growers in a region or growers that are working for you as part of a cooperative, you have growers that are really diligent, that will do what you tell them to do and measure and record what you tell them to measure and record, and you'll have others that will do it in a rush. And the poor data may undermine the good data. So crowdsourcing and citizen science may have a role. And of course, we're creating more and more data from our fields and our orchards as we speak. We've gone past the days of $2,000 soil moisture probes on self-healing mesh networks on poles. This is a $150 soil moisture probe that will transmit that soil moisture information 10 kilometres. Right, so we're facing a future where farmers and growers will be throwing stuff like this out everywhere. And we, as users of the data, be it a business or people who want to understand the agronomy of what's going on in our candidates or our clients' farms, we need to know how to pull that data all together. And the maths behind what we measure is getting so much smarter. That NDVI that we hear about, that we try to use it to get to photosynthetically active biomass, be it in a tree or be it in a pasture or in a crop. But it turns out, and there's an increasing amount of evidence, that this NDVI is better at predicting growth rates than it is in predicting how much you've got there. And that's an interesting little subtle point to make, that the NDVI seems to be shaping up to be more accurate in predicting the growth of a plant, the rate of growth of a plant, than it is in how much biomass is actually on site. And that's something I'm really keen to interact with some of the scientists in this institution with, for example, because you're ahead of the game in some of the modelling, and this sort of stuff I think could be quite useful. But at the end of the day, if we're going to have a precision anything in agriculture, we need our connected farmers. And so I'm putting a sort of a semi-political hat on here, and hence the influence. Barnaby's in our electorate, so he gets an earache from me every time he walks down the street. If we've got potential citizen science going on in our farms that will help understand the agronomy of what's going on, connect us to our clients, our contract growers, and our candidates, then everyone's got to be connected. So we need good, reliable, high-speed internet. That's got to be fundamental, critical infrastructure for our farming. In the grape and wine industry, put yourself on a harvester when you should be harvesting Chardonnay at 2 o'clock in the morning, as we were supposed to be doing about 2 years ago. We spent the whole damn night fixing a cross-conveyor belt in a damn harvester. Now, if we could have had a chat, as we now can do, with our mechanic back home, with the head cam on under that belt, then we would have known there's a couple of tricks you could do to actually set the tension reliably in your cross-conveyor and keep it there under the high RPM, but we didn't know, so it cost us a night of harvesting. But that can now be done thanks to a little wireless head cam and good high-speed internet between the shed and the farmhouse through a high-speed Wi-Fi and the farmhouse to the outside world. It's critical infrastructure. That's what precision horticulture is. We all hate pests, but this is an example of some of the inventiveness of some of our growers. They're not horticulturists, but it may be food for thought for you. Network camera on a tree, pig feeder at dusk every night. And after a while, the pigs get used to it. They come around, go in, have a bit of a snuffle, go back out again. And of course, there's the cunning ones that never come in unless you sit there and wait. But you watch a movie while you're having tea and you just thump the red button, and then you can sneak out next day and whop them. Now, that's a connected farm. If you've got a wild dog problem, as our sheep farmers do, we know it costs $27 million a year to our livestock industry. Another example that might be food for thought, sentinel shepherd. These are cameras mounted on sticks around the farm. The image processing looks at that and says that's a dog. Looks closely at it using pattern recognition and feature-based analysis. That's actually likely to be a wild dog. Bang, there's a smart dart dispenser just below the camera. Now, ideally it'd be nice if you could just blat it and just forget about it, but it doesn't work like that. What you do is you hit it with a tranquiliser, put it to sleep, and then come out next morning and just sort of lift it up and say, oh shit, there's a possum. Tap, 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 tap. Up in the tree you go, buddy. Bring it back to life, and then you maybe knock the dogs at the end. But this is what connected farming is about. Now think of yourselves in an industry. What are the options? The computing and the analysis and the physical dispensation of the smart dart, that technology is here. So can we pull it together in a different way? And of course, we're in the business of education. And if we're talking about precision anything in agriculture, and precision horticulture as an example, our commitment as educationalists and as trainers has to be to put kids in touch with this technology and the data right from day one. Otherwise, we're not preparing them for the real workforce they will walk into. So connected farms and the data streams that we get off of our many connected growers is a